One more lesson until spring break. Woohoo! Okay, so the lesson is on the circle theorem. So a little bit more algebraic today before you've been doing a lot of geometric stuff with looking at the angles and all the definitions and the pieces of a circle and their tangents and secants and chords and how they intersect and what kind of angles they make and relationships between them. Today we're just going to focus on the actual equation of a circle, and that's more algebraic. We're going to plug in numbers. We'll be able to identify the radius or the center based on the equation that we see. We put this section in here because we've just learned about the Pythagorean theorem, which relates to the distance between 2 points we discovered last unit. But now we can apply this to the circle because the radius is now the distance between 2 points, and if we keep that distance between the 2 points consistent, it will form a circle. That's the definition of circle. And the equation of a circle stems from the Pythagorean theorem, which is also the distance formula, where that stems from. So let's look and see how that is. So I gave you some pictures of circles here. And if you look, it says this information, the center is here at 1, 3, and the radius is at 5 units. Well, how do we know that? So I could look horizontally and say, okay, well, from here to here, if I go along the horizontal distance, and I have a grid, so now I can actually just count, right? 1, 2, 3, 4, 5. So clearly, that has a radius of 5 units. We could also go vertically, count 1, 2, 3, 4, 5. Clearly has a radius of 5 units. But what happens if I go diagonally? So let's say I choose a point. This looks like it intersects right here at a specific point, and I make this radius. Is that so obvious that it's a length of 5 units when I go up diagonally? Not really. It's not to me. Let's look at the ordered pair. We go to the right 4. Looks like we went to the right 4 and up 7. Right? So again, I told you this was going to relate to the Pythagorean theorem. Well, if we wanted to check this distance right here, we could create a right triangle and then just check using the Pythagorean theorem. What would you do? Well, because we have a grid, we can just count 1, 2, 3 units, but mathematically, we can take this 4, right, and subtract the x-coordinate of 1 from it and square it. Plus, then I'm going to do my y difference, which I can see is 1, 2, 3, 4 units. But again, if I don't know that for sure, then I can take my y value, which is 7, and subtract my other y value, which is 3, and square it. And then that should give me the radius squared, right? So it's this distance, which we said was 3, this distance, which we said was 4, so 3 squared plus 4 squared equals the radius squared. You can see it's a Pythagorean triple, a 3, 4, 5 right triangle, right? And if we continued our math, we would get r squared equals 25. I'm simplifying this over here, so therefore r equals 5. So that just proved that our radius is still 5 units going up diagonally. Now, like I said, this right here, doesn't that look familiar? That is your Pythagorean theorem, right? Or that's also your distance formula if we took the square root of both sides. So again, this distance circling all the way around, that's the same distance, which is what defines a circle. So now let's say we chose any number out here, x, y, around the circumference of the circle. Well, instead of having a 4 here and a 7 here, we could replace these with their x and the y, and we could always calculate the radius based on that. So what you'll notice then is that this 1 and this 3 are the center. And notice there's a minus sign in here. So part of the formula, or the theorem, the circle, you need to have a minus sign here. What happens if it changes to a plus? Right? Think about that. If I had x plus 1, the quantity squared, then where would my center be located? Would it be to the right of the y-axis still, or would it switch to the left? of the y-axis. Okay, so let's try the next one. Here we have a center at 5, 3. It has a radius of 3 units. Again, we can count it horizontally and vertically. It's obvious. But if I wanted to identify an equation of a circle for any point out here on the edge of the circle, right? I wanted to create a right triangle. Then what am I going to do? This center point is 5, 3. Again, I'm going to do x minus 5, the quantity squared. I'm going to do y minus 3, the quantity squared, and that's going to give me r squared. Well, what is r? We're saying it's 3 squared, or 3, so 3 squared is 9. So right here, this is an equation of this circle right here. We replace the 5 for the x-coordinate, the 3 is replaced as the y-coordinate, and then the radius over here. And this is just the Pythagorean theorem, remember, or the distance formula. Let's look at the third one. Center is 6, -1. Radius is 4 units. Again, we can see that very clearly. So if I chose a random spot out here on the circumference, what would the equation of the circle be? It would be x minus the x value of the center squared plus y minus the y value of the center, but a double negative changes it into a positive. So I'm just going to put y plus 1, the quantity squared, and that equals my radius squared. So the equation of the circle, of this particular circle, is x minus 6, the quantity squared, plus y plus 1, the quantity squared, equals 16. Notice I'm not solving for this, I'm just identifying what the equation of a circle is. That is the equation of a circle. That means I can plug in any x or y value on the circumference, and if I do, it's going to make this statement true. The left-hand side will equal the right-hand side. So the general formula then, if the center is A and B and the radius is r, would be x minus a, the quantity squared, plus y minus b, the quantity squared, equals r squared, where a and b represent the center and r represents the radius. So now let's go the other direction. If I gave you the equation of a circle, you should be able to identify the center and the radius. So the center, remember, is the x-coordinate and the y-coordinate that are paired with the x and the y in the theorem, or in the formula. So we want to have a minus sign here, so if it is a minus sign, then we're going to put a regular 3 here, a positive 3. If it changes into a plus sign, that means a -5 was put into the formula. So we have to write a -5 here. And then is 9 the radius? Nope. 9 is the radius squared. So therefore the radius is the square root of 9, which is 3. Let's try the second one. The center, we don't want a plus sign, we want it to be a minus. That means we input a -7. So this x-coordinate of the center of a circle is -7, and the y-coordinate of the center of the circle is positive 11 because there is a minus sign there. So here's my center, and my radius is equal to the square root of 36, which is 6. Finally, this last one looks a little bit trickier. The center, what would it be? Well, again, what do we have here? We have a 2. What do we have here? It's just y squared by itself. If it's y squared by itself, that's the same as putting y minus 0 squared. So the y-coordinate of the center is 0 because there's no number here that's inside the parentheses. Okay, the radius, however, is a little bit trickier. It's not a perfect square. 54 is not a perfect square, so we have to take the square root of 54. But guess what? You have to rationalize that. So there's a perfect square factor that's part of 54. It's 9. 9 times 6 equals 54. Therefore, right, 9 times 6 equals 54. Therefore, my radius is 3 root 6. My center is 2, 0. So you should be able to recognize or be able to write an equation of a circle based on the picture that you see. You should be able to recognize the center and radius from an equation that is given. And then you should be able to take the center and radius and create the equation. Okay, so the final step is to take the center and the radius and put it in this form up here. So my x-coordinate is -4, so a double negative makes a positive. My y-coordinate is +4, and then my radius squared is equal to 1. If you want to pause now and try the last two on your own, please do. Go ahead and pause and come back to it. So continuing this time, we have a -8. So with that negative, the double negative turns into a positive. We also have a -3. So a double negative turns into a positive. Now how do I square 2 root 3? So do a little side note for yourself. 2 root 3 times 2 root 3. Well, I have to multiply 2 times 2, that stays on the outside. Root 3 times itself is just itself. And 4 times 3 is 12. So 2 root 3 squared becomes a 12. So my more nicely written equation is this right here. X plus 8 the quantity squared plus y plus 3 the quantity squared equals 12. So we're looking for simplification of your radius when possible. You shouldn't just put r squared in there, you should actually calculate what that is. And your final problem, should look like this. If you didn't get that answer and you have questions, let me know in class next time I see you. Otherwise, I'm hoping you can figure out how I got 11 on the right-hand side of the equal sign instead of root 11. I will see you soon to work on the very short amount of problems during class after the quiz, and then hopefully you will go away for spring break with nothing to do. And maybe the Monday we get back, you can watch the video for the final segment in class and then start on the assignment because we'll have a review day after that. See you soon. Have a great holiday. Bye.